Good morning. From NASA's Wallops Flight Facility in Chincoteague, Virginia, I'm Stephanie Shearholtz in NASA's Office of Communications, and we're here this morning to talk about the Northrop Grumman's 10th Commercial Resupply Services mission to the International Space Station, which will be delivering about 7,400 pounds of critical cargo and supplies for the International Space Station. Joining us today to discuss the mission are Joel Montalbano, the International Space Station Program Deputy Manager at NASA's Johnson Space Center, Frank DeMauro, Vice President of the Advanced Program Division at Northrop Grumman, Kurt Eberly, the Antares Vice President at Northrop Grumman, Doug Voss, the Deputy Chief of the Range and Mission Management Office here at Wallops, and Tara Rutley, the Associate Chief Scientist for Microgravity Research in NASA's Office of the Chief Scientist. With that, we'll get started with you, Joel.
All right, well, good morning again, and welcome to Wallops Island. I want to thank Northrop Grumman, the Mid-Atlantic Regional Spaceport, and our international partners for getting us to where we are today. We have a rocket that's ready to go, a spacecraft that's ready to go, but as most of you have heard, the weather is going to require a 24-hour delay. And so the next opportunity that we're going to look at is on Friday morning at 04:23 local time here. And you'll hear more about that when the weather guys talk and kind of give you why we got, or how we got to where we are today. I will tell you that we've been working hard. This will be the second Cygnus spacecraft visiting the International Space Station this year. So far, we've had 5 commercial crew vehicles visiting. After the launch of this 10 mission, we'll have the SpaceX mission in early December. So a busy year, continues to be really busy on the International Space Station. In addition to the launches you're seeing domestically, we have a Russian Progress launch scheduled for November 16th, and that'll be docking on November 18th. And so what you'll see with the launch on Friday of the Cygnus spacecraft, Antares rocket, you'll have a berthing early Sunday morning. And right now I'm showing a berthing of about 4:30 local Eastern time. And then about 19 hours later, we'll have a Progress docking to the International Space Station. So without a beat, we continue working on the International Space Station and moving forward. Looking past that, for the remainder of the year, we have a Soyuz spacecraft launch that we're currently targeting for December 3rd. We have a flight readiness review later this week. And then, assuming that goes off well, we'll have a SpaceX mission right now. We're saying no earlier than December 4th. And then the Soyuz landing on December 20th, bringing home the crew that's on board the International Space Station today. As was mentioned earlier, we're carrying about 7,500 pounds of supplies, research, utilization, maintenance, everything we need to keep the International Space Station moving forward and doing the critical research and science that all you are accustomed to. As far as looking at consumables, we're good on board. Our limiting consumable is food, and right now we're good with no resupply until May of next year. So we're not really tracking any type of consumables issues. And then, I gave you the schedule for this year. Looking forward in the next year, we're really excited to bring on our U.S. domestic commercial crew providers. So SpaceX, we're targeting the demonstration, the uncrewed demonstration mission in early January. We'll have the Boeing uncrewed mission in March. And then our targeting is planning for both crewed missions for both SpaceX and Boeing later in the year. So with that, I'll hand it over to Frank, and we'll be ready for questions at the end. Thank you.
All right, thanks a lot, Joel. Good morning, everyone. Welcome back. We're certainly excited to be back here at Wallops for our Northrop Grumman 10 mission. We want to thank all of our mission partners, particularly NASA Wallops, the Mid-Atlantic Regional Spaceport, and the Virginia Commercial Space Flight Authority for all their support in getting this, getting ready for this mission to come up in the next couple of days. I do want to, it's only been a couple of days ago, so I do want to say Happy Veterans Day to all the veterans out there watching. Thank you for your service to this great nation. And also to the Marines, happy 243rd birthday that occurred last Saturday. So, and I might as well throw in a happy 252nd birthday to Rutgers University, my alma mater. So, while I'm at it, a couple of thank yous. It's been a lot of preps going on for this mission. I do want to say thank you to the Antares team who, out in the driving rain in the cold the other day, rolled the vehicle out to the pad. So thank you to them for their dedication to the mission. And also to the Cygnus team who modified the processing schedule of the vehicle here at Wallops to allow NASA a little bit more time to work through some potential cargo swaps. So great job by both teams being flexible and working through the elements that we're working through. So we've got a short video to talk about the preps for the mission, if we could roll that. So our service module is built at our facility in Dulles, Virginia. That gets trucked here to Wallops and delivered to the H-100 facility where it's unloaded and gets ready for some launch site testing and preps. Here you can see the cargo module being delivered. It comes from Italy. Our partner, Thales Alenia Space, there delivers it by boat, and it arrives here at Wallops. Then we start to load the cargo into the cargo module before it's mated to the Cygnus vehicle. We load about 2/3 of it during that phase. And once that's done, then we'll actually mate the cargo module to the service module, creating the Cygnus spacecraft. And actually, this is the first time these modules actually meet, is here at the launch site after the initial cargo is loaded. After that, it's moved to V55 where it's fueled, and then we install the NanoRacks external CubeSat deployer. It's something we've done on several missions now, and we'll do it again here, where we'll deliver 3 CubeSats in orbit after the mission. Once that's done, the vehicle will be moved over to the horizontal integration facility where we go through the process of being mated to Antares. All the mechanical connections are made, the electrical connections are made, and everything is checked out to make sure the payload and the rocket are communicating and ready to go. We'll then let the crew go back in, our crew, go in and load what's called the final load. It's a good bit of the remaining cargo gets loaded right before we get encapsulated in the fairing. And it's the cargo that goes in late. NASA delivers it a little bit later, gives them more flexibility. And here you can see the inside of that cargo module with our crew strapping down the cargo. That volume is important, not only for bringing a lot of cargo up, but also for allowing the crew to stow a lot of disposal cargo for us to take away. And here you can see the vehicle was encapsulated, and then the launch vehicle was rolled out, getting up onto the ramp. After liftoff, about 10 minutes or so after liftoff, the spacecraft will separate from the launch vehicle. We will then go through the process of deploying the solar arrays, doing an initial checkout. And here you can see the deployment of our UltraFlex solar arrays. Those are manufactured by Northrop Grumman's facility in Goleta, California. We've flown them on several missions, and they've been a resounding success for the satellite. After we do that and we raise the orbit up to the space station orbit, we'll begin our rendezvous process, where we'll get below the space station and start our trek up towards the space station on what's called the R-bar. We'll do that from about 1,000 meters up to about 250 meters. We'll hold, get to about 30 meters again and hold, and eventually when we get to about 10 or 11 meters below the space station, we'll be grappled by the robotic arm that's operated by the crew and eventually connected to the space station and become part of the space station. In this case, we will be on the station for almost 3 months' time. Once we're berthed, the crew will open the hatch, they'll remove the cargo we brought, they'll fill it with the disposal cargo, and then eventually we'll be unberthed and let go. And we will begin our post-berth mission, where we'll actually deploy the CubeSats. In this case, we're going to do it from both above the space station orbit and below the space station orbit. First time we're doing that. And you can see a video of the CubeSats deploying on a previous mission. Once that's all done, then the vehicle will make a safe re-entry over the South Pacific roughly 2 weeks after launch. And we're naming this mission in honor of John Young, just a pioneer of human spaceflight, inspirational leader who flew on 2 Gemini missions, 2 Apollo missions. He commanded the first space shuttle mission as well as a second space shuttle mission. So he's a hero to so many people, and we're honored to name this mission as the SS John Glenn. So with that, I will hand it over to Kurt.
Thank you, Frank. I would also like to say we're, on behalf of the Antares team, we're really excited to be back here at Wallops with our NASA and Virginia space partners for the NG-10 mission after a very successful OA9 mission this past May. It was May 21st. Went very well. Everything looked really good from that mission and very close to the prior 2 missions of this configuration of Antares. For those planning to be outside at the viewing site, we're down in the temperatures in the 30s, so much better than last year's OE8 launch. So I'm trying to give you a shred of good news for some of you that I know were here last fall. I'd like to recognize Dale Nash and the Virginia Space Team who operate and maintain the spaceport and Pad 0A for us. An outstanding job and excellent support that we receive from the Commonwealth of Virginia. I'd also like to recognize Bill Robel, Jeff Reddish, and Doug Voss here from the range, and the rest of the Wallops Range team for the outstanding support we receive in planning and preparing for these launches. I think I have a video to roll too that talks about the integration of the Antares and the Cygnus. That's our mission patch. We have an employee patch design contest, and that was the winner. Our folks get enthused about that. Here you see the inside of the horizontal integration facility. We process 2 vehicles at a time. In this case, you see NG-10 and NG-11, which is slated to launch next spring. After being fueled, Cygnus was moved into the HIF on November 1st. The ops team rotates Cygnus from vertical to horizontal, and then we made it to Antares. We then moved the cargo loading equipment into place, and the Cygnus team loads the late and final cargo delivered by NASA. Here we see some parallel work on the NG-11 vehicle, which is slated to launch in the April timeframe. You can see a motor cone being installed over the nozzle of the second stage Castor 30 XL, which is built by our Propulsion Systems division. And next you can see the fairing being prepared. We position this in front of the vehicle to get it ready to be mated as soon as the cargo hatch is closed out and all the cargo is loaded. What we do is we roll the fairing aft over the top of Cygnus, and we attach it to the aft separation joint at the base. And you can see that activity here. After we do that, we install our rain tarp over the fairing, since we knew it was going to be raining Monday night when we rolled out. And then we move out of the HIF using our over-the-road transporters underneath the tail, and we go about a mile south on the island to launch Pad 0A. And here we told our team to really hurry it up, so they're scurrying out of the HIF. And then up the ramp, you'll see at the end, we connect to some pistons buried in a pit at the pad, and that pushes us to vertical. Fueling starts about an hour and a half before launch, and then we ignite the engines at L0, and we do a quick health check at intermediate power level. Then we throttle up, release the vehicle, and away we go. Antares will fly straight up for about 25 seconds, after which it will pitch over and head downrange in a southeasterly direction. At a little over 9 minutes after liftoff, Cygnus will be separated into orbit. Earlier this morning, we were preparing for a launch tomorrow morning, so we completed our major pre-launch verification test. We call that the Combined Systems Test. And that verifies all the connectivity between the Antares rocket, the Cygnus spacecraft, the launch pad, and the range. This went smoothly, and we are now in final closeout activity and preparation for starting the countdown. We will give our team a crew rest day because of the weather situation, and we'll pick it up again tomorrow night as we arrive on console about 9:30. We'll open the countdown a little bit after 10 p.m. local time tomorrow night, and we have a 6-hour, 15-minute countdown to get to the L0 time, which, as Joel mentioned, is 4:24 local time in the morning. It's a 5-minute launch window. We will target the opening of the launch window, and that gives us just a little bit of flexibility there on the timing. All right, finally, I'd like to say a word about public safety and airspace clearance. This is my standard public service announcement. Some of you may have heard. We have had some past launches where we've had boats and airplanes travel into the restricted area that forced us to scrub the launch for the day. I'd like to encourage everyone who's coming for the launch to please follow the directions of the Wallops Range, the FAA, the state police, and other public agencies who are working to protect you and ensure the safety of the public. We all want to see a good launch on the first attempt, so I appreciate all your cooperation, and we appreciate the extra work the Wallops Range has done to raise public awareness, particularly within the general aviation community. Thank you for being here, and we're looking forward to a good launch on Friday. Doug?
Thank you, Kurt. So once again, the Wallops Range and the Mid-Atlantic Regional Spaceport has been working together for months to bring us to a ready state, a go state, to support the launch of the NG-10 for Northrop Grumman and the NASA COTS mission. So this will be the 8th launch from Wallops of the Antares launch vehicle. We're going to talk a little bit about weather. I think folks are really anxious to see that, so we have a slide on weather. Okay, so this morning we had launch readiness review at 8 o'clock, and one of the major factors was launch weather. We have a probability of violation of 90% for launch for Thursday morning. So as you can see there on the slide, primarily it's because of thick clouds and disturbed weather and low cloud ceilings. And these are important launch criteria for safety and for the reliability of the launch vehicle, particularly associated with lightning in that problem. So another likely violation is life safety situations for boats and aircraft participating in the operation. The launch constraints associated with the operation of those craft can be a problem in that type of weather. So the panel this morning decided to delay and reconvene Thursday for a review of the situation for a Friday launch time. On a brighter note, next slide, Wallops Flight Facility just recently completed an update to the Wallops Bermuda Tracking Station. Next slide, please. So this is a $5.3 million renovation and outfitting of the Bermuda Tracking Station. We conducted a ribbon cutting earlier this month and used the opportunity also to conduct some STEM outreach, STEM engagement with Bermuda schools in the area. Wallops has been operating that Bermuda site as a mobile range location for a number of years, and this upgrade will bring greater reliability and reduced operating costs for the mission farm from Wallops. The site will contain tracking, telemetry, radar systems, command systems to enable safe and successful conduct of launches from Wallops and the Eastern Range. So we anticipate this site will be used for missions to the moon and to Mars and beyond in the future. On behalf of the Wallops Range, we appreciate Northrop Grumman's choice of Wallops and the Mid-Atlantic Regional Spaceport as their launch location in support of an important NASA mission. So aside from weather conditions, the Wallops Range is currently a go for launch operations, and we'll sit tight and see what we say tomorrow morning in terms of reassessment of those conditions.
Thanks. You know what, Frank, in the spirit of anniversaries, I do believe Joel and Stephanie, do we have a few important anniversaries ourselves with ISS?
Yeah, we're celebrating 20th anniversary of Space Station this year. Unbelievable. You know, we reach out to over 100 countries, have done research or an education event or any type of activity on board the International Space Station. We're not stopping. And so this is 20th anniversary. We're looking forward 18 years with crew on board, and we're not stopping. We're going to keep going, and we're looking to at least double that and do some more, at least my hope anyways.
Yeah, so let's do this, right? So, starting with this particular launch, we're going to enable the delivery of several new investigations to the space station, as well as supplies that will enable over 250 different investigations to happen on station over the next 6 months. I'll share with you today just a few, although there are many more that I'd like to talk about. But you can go to nasa.gov/ISS-science to learn more about the science beyond today. The ones that I'll talk with you today were developed by investigator teams who are inspired by how the space station offers them a new and different way of doing research. Some are inspired by their role in contributing to human exploration beyond low Earth orbit. Others are inspired by the potential breakthroughs that they may get in their own research that will result from using the unique environment of the space station. Certainly all have been challenged to think through processes and behaviors that aren't always intuitive for them as they would be here on Earth, where the gravity force is really, really strong and doesn't change. I've had a chance to meet with many of the researchers over the last few days and the students associated with this flight, and some are excited newcomers and new faces to ISS who I've never met before, small businesses, and others are experienced space science veterans. All are as excited as ever to see their hard work and their promise head to ISS on this particular NG-10 launch. In the area of human exploration, we are sending up a refabricator from the small business Tethers Unlimited in conjunction with Marshall Space Flight Center. They'll demonstrate the first ever integrated 3D printer and recycler in space. It recycles waste plastic, potentially, materials into high-quality 3D filament for the 3D printer, providing the potential for sustainable fabrication, repair, and recycling of plastic materials on long-duration space missions. So it's a key part of NASA's in-space manufacturing tech demo roadmap. There's another investigation when you think about sustaining humans in beyond low Earth orbit. That's the MVP Cell 5 investigation. And it's going to look at the complex process of cement solidification. This team is interested in the future of making and using concrete on extraterrestrial bodies like the Moon and Mars. Earlier this year, this Penn State University team performed cement solidification in microgravity on space station, and they got their samples home and found some interesting things that caused them to want to reiterate their science again in space. So this particular time, what they found, what was really interesting to them was as the cement solidification process proceeded in microgravity, their samples they got back, they saw really large crystals in the materials. And so that's likely due to lack of sedimentation and convection forces associated with just being in the microgravity environment. And that's an interesting finding for them to further study. So now they want to send up their next investigation on this launch, looking at cement solidification again, but this time using the new centrifuge capability, small centrifuge capability that we have on space stations so that they can form their concrete under different varying G levels, such as the Moon and Mars. Coincidentally, there's also a student investigation headed to ISS on this flight that'll examine bacteria calcification in the pores of broken concrete in microgravity as a form of self-healing. So we have 2 concrete investigations unbeknownst to either of these teams. I met the students yesterday. They are from the Higher Orbits Go for Launch program, where student design experiments for a chance to compete and send them to the space station. They were excited to hear about the other investigation, and they're actually looking forward to making connections with those investigators and talking about results and potential go-forward opportunities. So really, they learned so much, and they're really inspired, and that's what we like to encourage, and that's why these in-person meetings are important and these interactions between space station scientists. So when you think about the future and ISS's role in the future of establishing longer-term human presence and infrastructures such as these on the Moon or Mars, these are the kinds of studies that we can do right now while we have complete access to ISS to help develop the technologies to do that. Also relevant to human exploration is the Vection experiment that will be performed by our Canadian colleagues. This study looks at how microgravity affects the complicated sensory systems that enable astronauts to perceive self-motion and also judge the distance of objects. And how that might be affected in microgravity. And it's studies like these that help ensure crew safety as we begin to explore further. A little closer to home, researchers are using the space station through the ISS National Lab effort to advance research breakthroughs on Earth. The Michael J. Fox Foundation is performing a second iteration of its protein crystal growth investigation. They're trying to discern the structure of the LRRK2 protein, which is responsible in the progression of Parkinson's disease. Knowing the elusive structure of this particular protein could help improve therapeutic treatment of that disease. This second iteration, in the second iteration, the researchers are going to use new space station capabilities to observe their crystal growth real time on the station, so that it's going to allow them to make changes in their process and methods as they iterate on board in the microgravity environment, much like what you can do in labs on Earth. Regenerative medicine is also a priority research area for the ISS National Lab, and on this flight, a company called MicroGRX will launch a lab-on-chip, fully automated, multifunctional cell culture platform looking at skeletal muscle cells. And this project will provide a model for microgravity-induced atrophy, or muscle wasting, while facilitating higher accuracy musculoskeletal disease modeling and therapeutic testing. These kind of therapeutic testings could actually help advance the way that we go through medical clinical trial processes on Earth. This is the first lab-on-chip investigation ever being done on ISS, and it's setting the stage for future technologies, such as the series of tissue chips in space, demonstrated by the National Science Foundation that's coming up on the next series of flights through the National Lab Partnership. But as Cygnus departs ISS, its science job isn't done until it deploys CubeSats that you heard about. That'll give students experiments in spaceflight hardware design and testing. It'll also test communication technologies. You heard a mention of first deploy of these things below ISS, and that are going to be, I think that's the series of 100 tiny little FIMSAT satellites. That are these tiny little chips that are looking to integrate a bunch of sensory and testing capabilities and put them out into the environment of space and see how the technology works. So our crews on orbit are looking forward to keeping busy with the supplies from this launch. It's why they're there. It's what they care about. They're excited about. They believe in it, as we do. And we're also looking forward to the advancements that come from a result of these investigations. Thank you.
Great. Thank you, Tara, and thank you to the panel. We'll now open it up for questions and get you some answers. First, we'll take some questions in the room. Then we'll go to any questions on the phone line and questions from social media. If you'd like to submit a question on social media, please use the hashtag AskNASA. And just to clarify 2 points before we begin questions, launch time is 4:23 a.m. Eastern Time, and there's about 7,400 pounds of cargo on this launch. So first question, we'll start with Ken. Is there a microphone? Sorry.
Hi, thank you. Ken Kramer, Space Up Close for NASA or Northrop Grumman. Yeah, you mentioned you might be changing the cargo because of the Soyuz launch failure. I wonder, did you actually make any changes in the cargo as a result of that? And for the Northrop Grumman guys, can you talk about weather conditions that would cause you to roll back the Cygnus, the Antares? I don't know if it's going to get anywhere near that, but what, in theory, are the rollback conditions? Thanks.
From a cargo standpoint, yes, we did make some changes. We have some medical hardware that was flying up on the Soyuz that will fly up on this vehicle. We have some spacesuit hardware, some thermal hardware to get us some more redundancy on orbit, as well as some life support hardware, both in the oxygen generation and the water recovery system. So we were able to work with our Northrop Grumman team. They were extremely flexible, let us go past our standard delivery dates, and we were able to get that hardware on, and it worked out great.
Yeah, to answer your other question, Ken, it would have to be some very severe weather. We're firmly attached to the launch mount, and we're held at the front with our gripper arms on the strong back. I don't have the precise numbers, but it'd have to be a high wind event akin to almost a hurricane to drive us off the pad. Other than that, we're very secure. We've got a lot of air conditioning blowing in all the dry bays of the vehicle and in the payload fairing, keeping Cygnus and our second stage nice and dry and toasty. So it would have to be something really severe, more severe than what's forecast in the next couple of days.
Okay. Question here.
This was either for Joel or Frank. Can you walk us through, Cygnus is at the station, the hatch is opened, and the cargo's coming through, but you got a variety of cargo going on board. What's the process in transferring the cargo from Cygnus throughout the various parts of the station? Thank you.
And so what we'll do is we'll prioritize the cargo based on what the crew is needed. So one of the first things that the crew will get out of the Cygnus spacecraft will be fresh fruit. We also put some ice cream on board for them, which we typically try and do, and the crew is pretty excited, so I expect they'll get to that early. Based on the needs of our timeline, so we'll timeline our activities. We'll have timelines for the Cygnus. We'll be getting ready for progress. There'll be some progress activities. So we'll kind of lay all that out, and we'll get out the equipment as needed.
Okay, I think there's a question in the back. Please raise your hand and get the attention of a microphone if you have a question, and then say who you are and to whom your question is.
Hi, Karen Bogoski, high school teacher. Tara, the 3D printer, how does it work with distributing the fumes that are generated from the recycling of the plastics?
Oh, that's a really great question. Is the refabricator team still here right now? I think I think that it's all enclosed, and I think they did address that to some extent yesterday. But it's an enclosed system that's managed somehow. I really don't know how, though. I don't know the details. Anyway.
Alan Williams, Zog 43 Rocket Newsletter. Just a quick question. Last year, this time, they snuck up a lovely turkey Thanksgiving dinner. Any chance that that's being snuck up, or is it just the ice cream?
We always protect for the major holidays, so Thanksgiving and Christmas, so we'll have some Thanksgiving, the typical Thanksgiving fixings will be available for the crew, absolutely.
Are there more questions in the room? We have two over here.
This one's for Kurt, Jason Ryan with Spaceflight Insider. Kurt, we got a little bit of weather coming in, and I know you guys are taking preparations for that. Can you give us a few examples of what you're doing with Antares to make sure that everything's safe to go for launch day? Thank you.
Yeah, there's a number of access hatches, and in our combined systems test last night, mainly on the aft end of the rocket, the aft bay is where we get in, and we make some connections to the ground, and we do various checks. Those are going to be closed out. We do some weather sealing on those, basically getting ready for launch. We're going to do today what we're going to do anyway, and then largely just stand down. So we'll kind of be battened down. All the hatches will be closed, and the weather sealing will be in place, and then we'll have crews out there. We have a crew support building very close to the pad, and we'll have a rocket watch activity where we are continually getting data from the vaults underneath the pad that contain all of our ground support equipment. So we'll get a lot of continuous monitoring of temperatures and making sure the air conditioning is running, and so it's a lot of monitoring, and then having backups for the power. In case power goes out, then we'll have a generator available so we can keep the air flowing into the dry bays. That's really the most important thing we'll be doing.
Yeah, hi. Rob Webb from Pequot Valley High School. I have a question from one of my students. They're wondering if there are any traditions that you guys do before a launch that may not actually be, doing anything, but is a tradition.
We decided, at least I decided a long time ago, I wasn't going to, have any launch superstition and wear a lucky tie or, a lucky pair of underwear or something. That could just get ugly. So we try to stay away from that kind of thing. We have some little traditions that we do, but they're kind of private, and they're just kind of crew teamwork type things that we do, but nothing too earth-shattering. So we try to just be very professional going into the operation, make sure we're prepared. We've trained properly, all our documentation's in shape, and we feel confident going into the launch operation.
Next question.
Hi, my name's Haley Harding. I'm a reporter with the Salisbury Daily Times. What is the cost associated with a delay like this?
Well, I don't want to get into specific numbers, but what's expensive is if we try to launch and then we don't. So if we just wave off for a day, that's not bad. We don't incur a lot of costs. We don't consume commodities. We don't bring the range up and so on. But when we do start counting down, Doug and his team, they're out at all the radar sites. We have the Bermuda site ready and waiting. All our guys are positioned and in place. That's where we incur some cost. And so if we have to scrub, then we end up expending some commodities. We boil off some LOX. We have to get more helium, recover all the kerosene. But so if we try and then we don't launch, we incur some costs. But we factor that in, and we're committed to doing this as many times as it takes to get a successful launch off, and we're not going to rush into it in any way. So cost is a consideration, but it's not the primary consideration.
So we have a question from Twitter.
Go ahead.
So about the CubeSats being launched from Cygnus, this is the first time you are doing this from separate orbits. Can someone address this and what the CubeSats are, what they're doing?
Yeah, so as far as the orbits go, it really depends on what the CubeSat customer is looking for. In this case, we have launched them from below before the ISS, and we've launched all of them, and we've gone above the ISS and launched all of them. And now in this case, we actually have customers looking for them to go above the ISS, and so we'll fly above, release them there, and then we'll go below and release the remaining ones. So it's really a function of what the customer is looking for. Typically, you get more life if you go above the ISS orbit, but from a science point of view, it is advantageous in some cases to go below. As far as the CubeSats go, one of the key things there that I'll talk about is the MySat-1 CubeSat. This is a CubeSat that was developed by a school in the UAE, United Arab Emirates, in partnership with Northrop Grumman, with the school, and so that will perform some scientific experiments, but mainly it was more about teaching the students how to build a spacecraft and how to launch and operate a spacecraft. And so that's something we're excited to be a part of, and we're looking forward to delivering that in orbit successfully.
Yeah, and I think the ones that go below are the tiny little femtosats. They're like tiny little circuit boards that can integrate, potentially a lot of different sensors. And really, they're looking to deploy these. They're called chipsets. And I think this is the Stanford University one. And they're just looking to test out how these boards survive. I mean, they're like really tiny. They're like 3.5 centimeter squared circuit boards. And from what I've read and from what I understand, there's going to be about 100 of them deployed. 105. Is that right? 105? Yes. 105. So that might be the reason for the difference in orbit. There's some things we need to manage there, but it's new and interesting. And I wanted, while I had the mic, I wanted to offer the teacher a chance to catch up with me afterward, because sounds like you might have some experience in 3D printing and want to know how we're handling the same situation that you're facing. Okay, yeah, I'm happy to catch up with you after and investigate myself with you.
Okay, great. Another question in the room?
Yeah, Alexander Stern with the German newspaper Süddeutsche Zeitung, with only a crew of 3 on board for some time. We are not eating as much, doing as much as a crew of 6. Are you making any adjustments on the amount of food, consumables, etc. you are delivering, or are you just stacking up as much as possible?
So it was going to be we were going to go from a crew of 3 to 5. There was only going to be 2 crew members on this last Soyuz. We are pressing forward. We anticipate to have 3 more crew members launching in early December, so when we get all the approvals through our readiness reviews. And so what we'll do is just increase our margins on board. The food has enough lifetime that we're not going to be able to throw any food away, as well as the other consumables. As far as science, clearly with 1 less person on board or 2 less people on board, you'll do a little less, activities on board, but it's just for a short time. And actually the crew members on board have picked it up, and they've been really working hard and picking up the things that had to get done. Any science or research that was time critical, it's being done, and we're reprioritizing other activities. So from that standpoint, we're doing actually very well.
Okay, and we have a question on the phone.
Yes, hi, this is Marcia Dunn of the Associated Press. Can you hear me?
We can.
Yes, probably for Joel. If you don't launch on Friday morning, would you go on Saturday and have 2 supply ships arriving on the same day? Might the Cygnus loiter until the Progress is docked? I mean, how would you handle that?
So I'll get the first part, and I'll hand it over to the Antares guys for the launch attempts. For a launch on Friday, we will have a berthing and a Progress docking on the same day. They're about 19 hours apart, and so that is the plan. As far as additional opportunities after Friday, I'll hand it over to the Antares guys, and they can give you the dates, or Frank, however you guys want to handle it.
Sure. We saw Doug's chart from the launch weather officer. Saturday looks like a very good launch weather day, showing less than 5% probability of violation. The LOs are trained never to put a 0% up there for fear of getting proven wrong. So that's a very good forecast for Saturday, and he told us also that Sunday is looking very good as well. So we'll give it a try for Friday, but Saturday looks better even than Friday.
And if we go, as Joel said, if we go Friday, we'll berth on the 18th. If we go Saturday, we would berth on the 19th, so that's Monday. And then if we were to happen to go Sunday, then we would berth on the following Wednesday. So, and all those days are available to us. So.
And what complications do you have in docking 2 vehicles, berthing 2 vehicles, docking in such close proximity? You only have a crew of 3, so it's going to be a little more intense for them in any event. How are you going to handle the crew side of all that?
Absolutely. So, we've talked to the crew about it. There's Alexander Gersh is going to be helping out his Russian colleague for the Progress vehicle. It's normally it's an automated docking, but they need to be prepared to go ahead and do a remote control docking. So we've worked with our Russian colleagues to train Alex and just give him. He's already had some training, but give him some refresher training to help his Russian cosmonaut in the event that they need to do that. As far as scheduling, because they're 19 hours apart, we're not seeing any issues. We've worked with the crews. We'll be adjusting their schedules a little bit, but no major perturbations to the schedule.
And one last question, if I might. Correct me if I'm wrong, but the turkey dinners are already on board. Is that correct for Thanksgiving?
That's correct.
Gotcha. Thank you.
We plan ahead.
One more question in the room.
Hi, my name is Jaren, and I'm coming from Boston. And my question is two parts. One is, with the delayed launch, does that affect the amount of time the capsule is docked to the space station? And the second part is there any plans for any parts of the Antares rocket to be reused in some way for a future mission?
Yeah, so we lay out all the undocking or unberthing and dockings throughout the year, and we'll assess that throughout the mission. Right now, a one-day delay isn't going to be a big change to us. We'll look at this mission. We'll look at other missions as they come and go, but right now, the February date is what we're planning to.
And Antares is fully expendable. We don't have any provisions for reuse at this time for any of the parts.
Okay, another question up here in the front.
Yeah, it's a simple question. My name is Farid Bozogmir. I'm from CSI Arts, which believes only in science and arts. And the question is, why it has to be precisely at 4:20 in the morning? Why is not at 10 o'clock a.m. or
At precisely 4:23.
I would be happy to answer that question. It's all NASA's fault. No, it's the ISS is in an orbit plane that's inclined 51.6 degrees to the equator. Okay, and the ISS is going around in this plane. Imagine that plane, and then imagine the Earth spinning once every 24 hours underneath it. Okay, so once every 24 hours, that plane is going to go over Wallops Island, and when that orbit plane is over Wallops Island, that's when we want to launch, because it puts Cygnus in the best position to reach the ISS with the least amount of fuel required to change its inclination. Changing the inclination on a spacecraft in orbit is very costly from an energy point of view, as opposed to just changing the altitude or changing the phasing within the orbit. So we try to make sure we launch very close to when that orbit plane is going right over top of Wallops Island. Now, the ISS may be on the other side of the Earth, but the plane of its orbit goes over Wallops Island. And so we give ourselves a 5-minute launch window, so that's 2.5 minutes on either side of that precise optimal launch time. So we book enough energy on the rocket to steer out those 2.5 minutes of error that we get on the inclination, and we still are able to give Cygnus, put them on that precise trajectory, which gives them the least energy to get to the ISS.
Technically, they can launch at 10 a.m. to make it more comfortable for you, but then they'd never make it to ISS. So that would not be good for either of us.
Okay, thank you. Thank you for all the questions today. Thank you to our panelists.
Stephanie, if I may, I have a clarification. Sure. Okay, my brain and my mouth did not connect earlier when I was incorrect when I said the National Science Foundation has a series of investigations coming up on the National Lab. That should be the National Institutes of Health. However, the NSF also has a great partnership with the National Lab, too. So those investigations are forthcoming, but I wanted to make sure that you knew the tissue chips in space will be an NIH investigation series.
Great. Thank you for that clarification. Mm-hmm. And thank you all for joining us for the news briefing today to discuss the 10th Commercial Resupply Services mission for Northrop Grumman to the International Space Station. Launch is targeted for Friday morning at 4:23 a.m. Eastern Time. NASA TV's launch broadcast will begin at 4 a.m. Eastern Time, so you can tune in and make sure you watch the launch with a berthing and arrival on Sunday morning, November 18th, with progress docking that evening, later that day. Thank you for joining us. You can follow along www.nasa.gov.